this one. Hey guys. So I don't think it's really going to be a deep dive because it is a lightning talk, but I will do my best. All right. So let's see if this works. So yeah, I'm Nikola. I've been in the team for about a year. Apparently, everyone's waiting to see what via IR will break, and apparently, will break everything. So yeah. So for those of you who don't know what via IR is, it's basically just another pipeline in the compiler for essentially not compiling Solidity directly to the EVM bytecode, but rather using the intermediate representation, which is one of the techniques the compilers use to essentially better generate and better optimize code. In the context of Solidity, this is YUL, or inline assembly, which I'm sure many of you know what it is, and you've probably used it before. But yeah, the way this works without VIR, so currently with our legacy pipeline, which is not technically legacy because it's still the default, but as you've probably had the opportunity to hear, we are going to make VIR default, which will make the current pipeline legacy. So internally in the team, that's how we call it already. But yeah, the actual process is fairly simple on a high level. You provide your Solidity code to the compiler. The compiler turns that into the EVM assembly, runs the EVM assembly optimizer on it until optimization opportunities are exhausted and your code is optimized, and then dumps it into bytecode. Now, the via IR pipeline is a little bit more complicated. Ooh, I have a teleprompter. The via IR pipeline is on a high level, not much more complicated. As you can see, it's a flowchart with 4 boxes instead of 3. So instead of compiling directly to the EVM assembly, it will compile to YUL, have the YUL optimizer run, then it will just keep going like it did before in the legacy pipeline with the EVM assembly transform and the EVM assembly optimizer. It is important to note that currently the EVM assembly optimizer is still running. We are currently investigating how much of that we can get rid of, but of course that's not something that we do lightly because really anything with code generation is a fairly finicky thing and we don't want to break anything. Well, we don't want to break much more than we're already going to break by introducing this, but yeah. And then you end up with the bytecode. So overall at a high level, obviously it's not a massive change, but it really is. In any case, this is going to make things easier for us in the future and for all of you. There will be some initial hardships, I'm sure. There will be lots of complaints, I'm also sure of that as well. But yeah, a little comparison. I guess I'll start from the elephant in the room. I'll start from the cons, which is going to be significantly slower compilation times. Unfortunately, it's kind of like the laws of thermodynamics. You can't get something out of nothing. So just by the fact that we've introduced this step of transforming code from Solidity to YUL, running the YUL optimizer, it's going to take a while to compile things. It's unfortunately one of the things you're going to have to get used to. For us as the Solidity team, we work in C++, so we are more than used to extremely long compilation times. But yeah, it's one thing. However, the actual via IR, I think, has been stable since March of 2022, so that's even before I joined the team. So it's been stable for quite a while. One of the main reasons we haven't made it the default yet is ultimately because of the debug data that Nick talked about, because that's one of the prerequisites. We don't really want to make this the default and break absolutely everything without letting anyone have a chance to recover. But yeah, at the moment, the actual pipeline is pretty much just as good as legacy, actually slightly better in terms of gas costs. It's a little bit cheaper than the legacy pipeline. There is a caveat. There are certain situations in which legacy is a little bit cheaper than via IR, but in the vast majority of cases, that is not true. Also, for anyone who's auditing, obviously reading YUL is significantly easier than reading EVM assembly, so that's a plus. And another, probably the biggest and the most noticeable one for most people is going to be the significant reduction in stack to deep errors. because again, using Yule makes stack allocation and stack optimization significantly easier than working with EVM assembly. Of course, it is important to note that's still not going to fully make these stack to deep errors go away. A lot of that, I guess, is kind of dependent on EOF and the EVM itself, but the actual reduction is significant, and in general, you won't have to apply any of those dirty scoping tricks for stack slots and function parameters and whatnot. But yeah, overall an improvement. The compilation time is significantly longer. That's kind of the only downside. And as far as the future is concerned, as Daniel mentioned, the plan is to release it in June 2024 and break everything apparently, because it will be a breaking release. So that will be version 0.9. The prerequisite, as I mentioned, for releasing it is going to be the debugging data format. And yeah, as far as everything else is concerned, we generally are going to keep working on making it better, both in terms of making the optimizer sequences better for optimizing the actual gas costs, and also to make them faster so that the actual source code that you provide to the compiler compiles more quickly, which is the last point. And yeah, of course, I mean, some of the things, as far as support is concerned, keep in mind when we make it the default, the legacy pipeline is still going to be there. It's basically just going to be the opposite of what it is today. So right now, if you want to use the VIR pipeline, you have to explicitly state to the compiler by providing either a CLI option or a standard JSON option to turn VIR on. In the future, when we make it the default, you're going to have to do the same thing for legacy. So whoever's using legacy, I know the guy from Maple, yeah, there he is. Hey, yeah, I know people are concerned about that. So we're not just going to drop the legacy support at all. We will keep maintaining it as long as possible, and as long as people need it. But yeah, that's. I think is that it? That's it. How much time do I have? Was I too quick? I was. By how much?
3.
What? What? 10 minutes? Yeah. Oh, 3. Oh, okay, that's not too bad. Better than Nick. Yeah.
Okay, any questions about VIR? No questions? There's one.
Why is this change needed in the first place? Not complaining, just interest, like why we Solid itself like decided to do this change in compilation.
Well, you mean why are we now introducing intermediate representation and the whole well, I mean this has been in development for several years now, so it's not a spur of the moment decision. Now the intermediate representation is essentially a compiler technique that pretty much every compiled language that you've used probably uses. LLVM, Java, pretty much all compiled languages use some form of intermediate representation because it's significantly, and I mean, if you want to look it up on Wikipedia essentially, or look at some material, it's basically it's a compiler technique almost. But yeah, it basically makes a lot of things easier. It makes code generation easier. It makes optimization easier. Some of the stuff like the SSA form, getting full SSA form essentially requires intermediate representation. Now you can, of course, compile directly to assembly and then probably backtrack from there to get something at a little higher level of abstraction. So as Nick was talking about, like looking through all of the push statements and whatnot, trying to figure out whether it's a declaration or an assignment, which is kind of what you need for a lot of this stuff. So this is basically just a natural way of doing things, having some medium level of abstraction slotted in between Solidity and the EVM assembly to kind of make that flow a little bit nicer and easier.
There's another question here in the front.
I'm just curious if you have ever considered using something like LLVM, for example, instead of making a new IR. I'm sorry if this is a question you get often.
Not really, because yeah, again, the whole 64-bit, 256-bit thing, the different word sizes, it's also just, yeah, Probably not.
Right.
No. Daniel can
I
probably
mean,
answer
I
that
could
question.
also elaborate. I mean, there's been a lot of attempts of compiling to EVM via LLVM IR, and none of them really worked out that well. So, yeah, I mean, the Yule idea is meant to be targeted at something like the EVM specifically, which so far turned out to work better. If somebody comes up with a way to actually do it with LLVM IR, I would be curious to see it, but so far it didn't seem like a viable option.
I mean, essentially, we'd have to write a new front end for the LLVM and a new back end for the LLVM if we wanted to use LLVM. But yeah.
We have one more question in our speaker lounge chat, so I'm going to read it out to you. What are some of the top reasons that Solidity code that compiles without via IR does not compile with via IR?
What are some of the top?
Reasons that code that compiles with the legacy pipeline does not compile with via IR.
Daniel can probably answer that better than I can.
Yeah, I mean, that increasingly shouldn't happen. There is some cases. I mean, one of the advantages of VIR compilation is that we can move variables from stack to memory, which is also a reason that we actually use more variables, which leads, without us being able to move variables from stack to memory, to more stack to deep errors. Once we can move stuff to memory, it yields less stack to deep errors. So the reasons are probably the use of non-memory safe inline assembly, which prevents us from using stack-to-deep optimizations, or special cases in which it's not possible in our method in general, like recursive functions. We haven't seen a case like that ever reported, actually. So we were always wondering whether we should do something about that, but so far it hasn't come up. But yeah, if there is any other cases and other things other than stack-to-deep errors reappearing, for which there are, especially in the recent compiler versions, mitigations, and it should hardly ever happen, we would be curious, so then report it.
Thank you. Okay, if there are no other questions, oh, another one. There.
I presume that this means that inline assembly blocks, which often make a lot of assumptions about the code context in which they're being inlined, are going to break with via IR, in fact, with any radically new code generation strategy that generates different patterns.
We don't expect, I mean, we have built it in a way that inline assembly should work just as well as before. So, I mean, it's even actually smoother in the VIR pipeline. We basically just have a translation of the identifier names and then inline it into the UL that we generate, because inline assembly is basically the same language. So, and apart from that, the compiler internal structures of kind of like memory layout and all that still stays the same. So there are some breaking changes in VIR that are subtle, like evaluation order of expressions that nobody should really rely on, and in inheritance situations. So please, if you do the switch, look at our documentation that describes those, but these things like assumptions about inline assembly shouldn't be an issue. The one exception is assumptions about memory. So we have introduced an annotation to inline assembly that's called memory safe, which is the user declaring that they respect our memory management rules that we also have documented, which is a prerequisite for us moving variables to memory from stack. But yeah,
Thanks.
Another question in the back.
Hi. Decompilers often rely on specific patterns found in compiled EVM code. So in that case, now you have two different optimization passes. Did you give any considerations on how that's going to impact them? I mean, probably they're going to have to be rebuilt from scratch.
So for the via IR pipeline, we have a separate optimizer. And then for the EVM assembly, obviously we have a different optimizer, and they both run. Technically, it shouldn't make much of a difference because by the time you get to the EVM assembly, the code should have already have been mostly optimized. And then you do have some other, you have the peephole optimizer, which is going to run regardless. I mean, you can turn it off via standard JSON, but that just runs everywhere, which is, again, a separate optimization technique. But if you're asking whether, like, are you asking whether there's a a problem with running the Yule optimizer on Yule and then the EVM assembly optimizer on EVM assembly afterwards, or?
Yeah, so you usually rely on knowing what the optimizer does so you can go backwards. So in that case, you'll have to know both steps to jump backwards twice. That was the question. So that's going to probably break some of the decompilers, or not?
Decompilation is more complicated, yes.
Yeah.
That's what Nick is about then, with the debugging data, to actually help that process of tracing back through all the optimizers. And we will try to provide debugging information from Solidity via IR to Yule to assembly all the way down. So that's a bit of a hassle for us, but we are willing to do that, and it's already working for source maps, and will hopefully be for the full debugging format. That's kind of the point.
Yeah, but if you have access to that format, you probably don't need a decompiler.
Yeah.
Yeah.
So for decompilers it could be a problem, but for us it's not so much.
Okay, thank you for all the questions. Wonderful. I love how this was already a collaborative effort. And thanks so much to Nikola for this talk.
Thanks everyone.